ॐ सहना भवतु सहनो भुनाक्तु सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै ॐ शान्ति शान्ति शान्तिः। Professor Golgo Chattopadhyay is here now. So I am requesting Professor Chattopadhyay to join.
Hello. Hello to everyone. So, first of all, let me first of all welcome you on behalf of the Psychology Research Unit of the Indian Statistical Institute. And as a faculty member of the Institute and of this unit, I would like to first tell you that what will be held over the next 2 days under the guidance of Professor Devdulal Dotto Rai is a rare opportunity, and all of you should, first of all, make great use of this opportunity, because these are the tools through which you will be able to understand the world. And when I say understand the world, let me come back to introducing our institute. So the Indian Statistical Institute it was started by Prashanto Chandra Mahalnobish. Just to give you a brief description of who this man was, he was a product of what is called the Bengal Renaissance. He was secretary to Rabindranath Tagore. He was trained in Cambridge, and while in Cambridge, he got exposed to what was then a very developing field, a very new field. It was called biometry. Okay. Now, you guys today might know about, biometric in Aadhaar and everything, and to give attendance in offices, you have biometry. It's exactly that same word, except that at that point of time, what it meant was, how do you measure characteristics of biological phenomena that have to do with life, and that may be plants, that may be anything, that may be, but not physics and chemistry. So to sort of distinguish from those existing fields, right? Because people were measuring pressure of gases, people were measuring moles, people were measuring magnetic fields, they were doing all of that. But biometry. And of course, he was fascinated by this field. There was a journal called Biometrica, and he got very involved with it. And when he came back to Bengal, he was quite convinced that this would be the field he would sort of pursue. And with time, the Indian Statistical Institute was formed, at first as a part of Presidency College, Kolkata, Bengal, and then as a sort of a self-sufficient institute of its own, where we are housed today. And one might ask, what is the relationship? Why do we have a psychology department in a statistical institute? And the idea is, statistics is a tool by which we understand how nature works, and we try to approximate or abstract the workings of nature. And given that human mental life, human behavior is part of the natural world, we are not something uh, that's the philosophy of science, that our behavior, everything are explainable natural phenomena, and they are not some supernatural phenomena. Hence, all the principles of understanding nature in its various forms, you could call it, archaeology, you could call it anthropology, you could call it psychology, everything, geography. If you use the tools of statistics, tools of statistical analysis, then the idea is we get a better picture. And in keeping with that motto, our unit, under the guidance of Professor Debdulal Dotto Rai, has long been conducting such workshops for the benefit of young scholars and also established faculty, in fact, anybody who would be interested. So I would like to welcome you on behalf of the department to embark on this great journey for the next 2 days. On to
Thank you, Professor Gargo Chattopadhyay, for introducing our unit, psychology research unit, as well as the contribution of Professor P.C. Malanovish. I am requesting all of you, please, one by one, introduce yourself and share what are the things you want to know from us. First, I am requesting Monalisa Patnaik. Monalisa, please.
Good morning, sir, and everyone. I am Monalisa Patnaik, currently working as an assistant professor at MITS, Raigada, Odisha. So, I am in the day 1 orientation training program on advanced applied psychometrics, that is TAPP23, organized by Psychology Research Unit, ISI Kolkata. I want to learn the technical session by Dr. Mursida Khatun, the classical test theory and limitation, and the technical session 2 and 3 of day 1 by Professor Dr. Debdulal Dotrai sir, hierarchical cluster analysis and R script by Dr. Debdulal Dotrai sir. I want to learn more about this topic, psychology.
Okay, thank you, Monalisa.
Thank you.
Please brief me about yourself, lovely Divedi. Okay, lovely Divedi is not here. Gayatri, Shweta, Ranjit Dhara, okay, Farah Ahmed,
Good evening, everyone. I'm Farah. I'm program coordinator in RPR IT, and I joined this course to understand the application part of these concepts. Because theoretical, we already, we have studied in our masters and in our graduation, but I do not know the application part of these concepts. So I've joined this course to understand all those application part of the concepts. Thank you so much.
thank you, Farah. Anthony Fernandez,
Good morning, sir. Good morning, friends. My name is Subedar Anthony Fernandez. I'm serving in the Indian Army and I'm pursuing PhD psychology in Pondicherry University. Recently, I have joined a systematic review literature workshop with Datta sir. And this advanced applied psychometrics, it will be helpful for my PhD works. And I have done all the masters, 4 masters in psychology through correspondence only. This online workshop and the initiative taken by Datta sir would certainly will benefit me a lot. Thank you, sir.
Thank you. Tapos De, Ananya Agarwal, Kavita Shahu.
Hi everyone, I'm Ananya.
Okay, Ananya, please.
I'm postgraduate from statistics. Right now, I'm working in Tata Consultancy Services in a psychometrics team. So I got introduced to psychometrics in my job. So I want to learn how to develop psychometric thinking, like how to connect
Okay.
statistics with psychometrics, so that I can apply this learning in my work.
Thank you, Ananya. I think you know Professor Ajay Konar.
Yes, I know him. I am working with him.
Okay, okay, that's nice. Kavita Shahu.
Good morning, sir, and everyone. I am Kavita Shao. I am honored to join in this training program. I am clinical instructor in Government College of Nursing and IDBG Hospital, Kolkata. I am pursuing PhD under West Bengal University of Health Sciences. I do not know the application of this concept. I hope that I much benefited from this training program. Thank you, sir.
Thank you. Miss Rakshita Bindal.
Good morning, sir. Good morning, everyone. I am Akshita Bindal, and I have I'm experienced in working for government as a young professional and consultant. So I was in the last I was working with the Competition Commission of India, where I learned about mergers and acquisitions. And what I look forward in this workshop is to revise my concepts of R script, which were earlier taught by Roy sir, and also to understand the structural equation modeling, and where can I apply that in economics, and is there anything where we can combine the economics and psychology for the betterment of the research community. Thank you. Thank you, sir, for giving me the platform to learn.
Thank you, Akshita. Babita. Mohul Minul. Hello, Mohai Minul. Shayon. Madhuri Nandi.
Yes, sir. Good morning, sir.
Good morning.
Myself,
Please introduce yourself.
Myself, Madhuri Nandi from College of Nursing, Arjikar Medical College. I am the clinical instructor of this college. Since 2010, I have completed my master's in child health nursing, and now I am a PhD scholar from Manipur International University. Now I am pursuing, and for that, this session, these classes, and will help me a lot. So I have joined this course. Thank you, sir.
Thank you. Divyani Banerjee.
Yes, sir. Good morning, sir. Good morning, all the respected faculty and all my friends. Today I am in Allahabad. But this class is very important. I am music power faculty of and to mental health planning. Psychometrics entirely to learn psychometrics. I joined regular students of
Okay, thank you, Debjani. Rambhu Mourjo. Now Shumana Shaha. Okay, now I am sharing the screen. So we learn about the advanced applied psychometrics in this 2 days program. Before that, I like to share that is what is psychometrics. The word psycho indicates psychology and metrics indicates measurement sciences covering statistics, mathematics, geometry, etc. Psychometrics is a field of study within psychology that focuses on the measurement of psychological attributes such as knowledge, abilities, attitudes, and personality traits. The goal of psychometrics is to develop and apply quantitative methods for assessing these mental constructs in a reliable and valid manner. Psychometric tools include tests, survey, and other assessment instruments designed to gather data about individual psychological characteristics. Psychometrics mainly deals with the psychological test theories. Key concepts in psychometrics include reliability, validity, standardization, and the norms. Reliability includes the consistency and stability of measurement over time and across different items and situations. Validity, the extent to which a test measures what it is intended to measure. Standardization, the process of establishing norms and uniform procedures for administering and scoring the test. Standardized tests allow for meaningful comparison between individuals or groups. Norms, statistical benchmarks that indicate how a particular individual score compares to the scores of a representative group, often a larger population. Now, what is called applied psychometrics? Applied psychometrics involves the practical application of measurement principles to gather data about individuals and make informed decisions in diverse fields such as education, means assess students' academic abilities, learning style, and progress. This includes standardized testing for admission, placement, and evaluating educational interventions. Ananya Agarwal, I think you will find some interesting issue here. Clinical psychology, to assess mental health, diagnose psychological disorders, and evaluate treatment outcomes. Next, human resources in personnel selection, recruitment, and employee development. And market research, that is measuring consumer preference, attitudes, and behaviors. It plays a crucial role in enhancing the objectivity and reliability of assessment in real-world context. In applied psychometrics, population is limited and sampling frame is small, but research design is strong, so that fixed or random errors that can be controlled. So this is very important because it follows the action research. Differences between psychometrics and applied psychometrics. Psychometrics mainly mean for construction of psychological test, but applied psychometrics is mean for construction of psychological tests to solve problems in everyday life. Another one, it is mean for assessing item statistics, item difficulty, discrimination, and guessing. Here, item statistics is used for understanding and management of programs. It is mainly used for action research. In psychometrics, it is meant for development of theory on test reliability and validity, norm, etc. But here reliability and validity coefficients are used for solving regular life problems. In psychometry, it is used for norm estimation. But here situation-specific norm is used for classification and management. In psychometrics, knowledge about applied areas is not much important here. But knowledge about applied areas is very much important here in order to explore variability and management. Applied psychometrics in action research. Action research is an approach to inquiry and problem solving that involves the cyclical process of planning, acting, observing, and reflecting. When combining action research with psychometrics, the focus is on using measurement tools to gather data and inform the decision-making process. Stages of action research: identifying a problem or research question first. Second one is the literature review. Third one, selection of psychometric instruments. Identifying a problem or research question, it includes defining a specific problem or question related to psychological attribute or construct. This could be an issue with an educational setting, workplace, or any other context where psychological factors are relevant. Literature review. Conduct a literature review to understand existing theories and research related to the chosen problem or question. This helps in establishing theoretical framework and identifying relevant psychometric tools. Next, selection of psychometric instruments. Choose psychometric instruments that are appropriate for measuring the specific psychological constructs of interest. This might involve using established tests, survey, or other measurement tools with demonstrated reliability and validity. If possible, situation-specific psychological tests can be developed. Fourth one, data collection. Administer the selected psychometric instruments to the participants involved in the research. This could include students, employees, or any other relevant population. Data analysis. Analyze the data collected from the psychometric instruments. Use statistical method to interpret the results and draw conclusions about the psychological attributes being measured. Action planning. Based on the findings, develop a plan of action to address the identified problem or question. This could involve implementing interventions, changes in educational practices, or modifications in the workplace environment. Next one, implementation. Put the action plan into practice. This may involve changes in teaching methods, organizational policies, or other interventions designed to address the identified issues. Observation and monitoring. Observe and monitor the effects of the implemented changes. Use psychometric instruments to continue gathering data and assess the impact of the interventions on the targeted psychological constructs. Reflection, reflect on the outcomes of the action plan and consider whether the implemented changes have been effective. This reflection informs further adjustment or refinements to the action plan. Iterative process. The action research process is cyclical and the steps are repeated as necessary. Continuous monitoring, reflection, and adjustment contribute to an ongoing improvement process. By integrating psychometrics into action research, researchers can systematically measure and address psychological factors leading to evidence-based decision-making and continuous improvement in educational, organizational, or other relevant settings. Now I am coming to the advanced applied psychometrics. Advanced applied psychometrics typically refers to the use of sophisticated and cutting-edge methodologies and technologies within the field of applied psychometrics. This involves the application of advanced statistical techniques, computer-based testing, adaptive testing, and other innovative approaches to enhance the precision, efficiency, and fairness of psychological measurement. Here are some of the key aspects of advanced applied psychometrics. One is the item response theory. Second, computerized adaptive testing. Item response theory is a statistical modeling approach used in advanced applied psychometrics. Unlike classical test theory, IRT models the relationship between an individual's ability and the probability of responding correctly to each test item. This allows for a more detailed and nuanced analysis of test performance. Computerized adaptive testing is an advanced form of testing that tailors the difficulty of test items to the individual test taker. As the person responds to items, the test adapts in real time, providing a more efficient and precise measurement of their abilities. This is particularly useful in large-scale testing programs. Multi-dimensional scaling is a statistical technique used to analyze the structure of psychological construct. It is often applied in advanced psychometrics to examine the underlying dimensions of a complex construct such as personality or intelligence. Neurocognitive assessment. With advancement in neuroscience and technology, some applied psychometric assessments incorporate neurocognitive measures. These assessments may use tools like functional magnetic resonance imaging or fMRI, electroencephalography or EEG to gather additional information about cognitive processes. Big data analytics. Advanced applied psychometrics may involve the analysis of large data sets to uncover patterns, trends, and relationships. Big data analytics can provide valuable insights into human behavior, learning, and performance. Machine learning and artificial intelligence. Machine learning algorithms and AI techniques are increasingly being applied in psychometrics to analyze complex data, predict outcomes, and personalize assessments. These technologies have the potential to improve the accuracy and efficiency of the measurement. Virtual reality and simulation. Virtual reality and simulation technologies are utilized in advanced applied psychometrics to create realistic and immersive assessment environment. This is particularly relevant in fields such as aviation, medicine, and military training. Cross-cultural adaptation. Advanced applied psychometric takes into account the challenges and opportunities presented by cross-cultural assessment. This involves adapting and validating measurement tools for use in diverse cultural contexts to ensure fairness and accuracy. Dynamic assessment. Dynamic assessments involve observing how individuals approach and solve problems in real time. This approach is more interactive and can provide insights into an individual's learning potential and problem-solving abilities. Privacy and ethical considerations. Given the increasing reliance on technology, advanced applied psychometrics includes a focus on addressing privacy concerns and ethical considerations related to the collection, storage, and use of sensitive psychological data. Okay. So this is all about the advanced applied psychometrics. So in this training program, we will teach you item response theory, hierarchical cluster analysis, structural equation modeling, and you will learn the art script. I think, do you have any question about the psychometrics or applied psychometrics or advanced applied psychometrics? Hello, Professor Mushida Khatun, have you joined?
Yes, sir. Good morning, sir. Good afternoon, sir. I've joined. So do you want me to start with my session? Yeah. Okay, sir.
Yeah. Okay. Professor Mushida Khatun is here now. She is from Gitam University, Vizag. She did PhD under my guidance from the Indian Statistical Institute. His Psychology Research Unit is her alma mater. So now I am requesting Mushida to present the lecture. You can share the screen.
Yes, thank you so much, sir, for inviting me for this workshop. Very good afternoon to everyone who has joined for this session. I am Dr. Mushida Khatun. I'm currently working in School of Humanities and Social Sciences of Gitam University. And I'll be presenting on classical test theory today. So, sir, before moving on, can I have some information as to what background do our participants come from?
Yeah, the students are mixed here, mainly from the medical background and psychology background. Few from other background like management.
Okay, got it, sir. Got it. So anyways, I have kept my presentation at a very basic level. So hopefully it will not be too tough for the participants to understand the basic concepts of classical test theory. So I'll move on and share my screen. Is my screen visible, sir?
Yes, it is visible.
Okay, sir. All right. Okay, so basically in this session, I will be giving a very general overview as to what classical test theory comprises of, what are its assumptions, where all can we find its usage, and finally closing with some of the limitations that classical test theory basically faces. So to begin with, the basic premise of classical test theory As we all understand that most of our research, be it from management or any clinical research study or any psychological research study, we mostly deal with the total test scores. If we are working with any assessment or tests, so much of our decisions or much of our interpretation of the outcome is based on a particular total score, which is arrived at or obtained from a particular administration of a test. These total test score is basically made up of multiple items. So we can understand that a total test score uh, is as good as the sum of its parts, that is the multiple items that total test score is made up of. So the basic premise or the basic foundation of classical test theory is based on this total test score, which is nothing but summation of scores on multiple items. So one of the very basic assumptions of classical test theory is that it has a raw score which consists of a true component or true score component and a random error component. So if we can see here, it can be represented as so. X equals to t plus e, where x is the raw score, and it can be broken into or decomposed into two components, that is true score and it is associated with a random error. What we mean by this is that if we are to, this is again hypothetically speaking, if we are to assess an individual, let's say I'll take my example only, that if I intend to assess myself on a particular test and I try to administer that over multiple or infinite times, the mean of those scores on those multiple administrations, and that by multiple we mean it can go on to infinite numbers of testing. So that basically comprises the true score. But as we understand that this scenario is next to impossible, it is not possible for us to obtain infinite number of scores or infinite testing sessions. So hence, true score is more of more of a hypothetical idea. So what we basically work with is the raw score or the obtained score that we get. But classical test theory, it assumes that whatever obtained score that we get, it comprises of a true score along with that an error component. This is the basic premise of classical test theory. The concern for classical test theory is basically to cope with the random error portion of the raw score. What we mean by this is that the aim or goal of classical test theory is mostly to somehow reduce this random error portion of the raw score, so that the outcome that we get would be that the raw score would be closely approximated to the true score. So lesser the random error, or if we can lessen the random error in our assessments or random error in our scores, the more the raw score reflects the true score. Okay, so this is what the classical test theory basically aims towards, or its goal is. Next, coming to the assumptions of classical test theory. There are a few assumptions that are associated with classical test theory. The first of them is related to how the random errors are distributed. So as I mentioned, that if we are to take multiple sessions for a particular assessment or test on a particular individual, and we happen to plot those scores on an x and y axis, it should, or the distribution should resemble that of a normal distribution. That is, the mean for all those scores should, or all those error components should come out to be as 0. That is the first assumption. Normal distribution of random errors around the true scores should be, the mean should be 0. The next assumption that we speak of here is that the random errors that we obtain or that we observe, they should be uncorrelated with each other. What this basically translates to is that if we are taking into context those multiple scores, the variation in the random errors should not follow any system. So that hence the term random. So let's say I intend to administer a particular test, let's say a test on any ability, for that could be any cognitive ability. Okay, if I intend to take that particular test for 2 years, each day I take the same test, and I happen to plot those scores for each day, right? So basically over 2 years I'll have basically 365 into 2, that many scores I would have. So if I plot those scores, it would obviously be a representative of the random errors, right? So the random errors that we observe should be uncorrelated with each other. Hence, some days if I get a low score, some days if I get a high score, this variation in my score should not follow any kind of system. Okay, there should not be any systematic variance. So hence, the second assumption revolves around this, which says that random errors are uncorrelated with each other. The third assumption here is random errors are uncorrelated to the true score, right? So we can see here in this graph here, we have three distributions of particular scores, obtained scores or observed scores. And obviously the true scores are basically the means of, or the mean of these distributions, right? Mean of all the scores that we have obtained. So the third assumption says that random errors should also be uncorrelated. It should have absolutely no relationship with the true scores. So true scores are completely independent of the random errors, which again continues from the previous assumption that random errors should not be systematic. From all these three assumptions, the last one is not really an assumption, it is more of a characteristic. It says that standard deviation of the distribution of random errors around the true score is the random error, standard error of measurement. So basically, if we are to arrive at a standard error of our measurement model, it basically is composed of the standard deviation of the random errors around the true score. This was about the assumptions of classical test theory. Next, we'll be discussing about some psychometric, how can we arrive at certain psychometric properties, since we are talking about tests and assessments. So classical test theory finds its usage mostly in gauging the psychometric properties of a particular assessment or tool. Okay. So the first property that we'll be talking about is reliability. How reliable or how consistent a particular assessment or tool is. So deriving from the idea of classical test theory, since we were talking about a hypothetical situation where it is impossible to administer a particular test infinite number of times, so psychometricians and mathematicians, they basically figured out a shift, or they figured out a way in which we can make use of this theory to arrive at the psychometric properties of any particular test or assessment. So basically, there was an extremely important shift in this approach, which was brought about by psychometricians. And they said that the theory of true and error scores developed over multiple samplings of the same person holds over to single administration of an instrument over multiple persons. So basically, if we see here that it says true and error scores developed over multiple samplings of the same person. So instead of doing that, psychometricians, they propose that, or they found rather, that the same characteristics or the same ideas of classical test theory, they can be upheld by single administration over multiple people, which is more feasible, right? So they found out that if we try to administer a particular instrument over multiple people, the same theory of true scores and error scores, they hold up in such scenario as well. From this particular ideology or this particular idea, uh, the reliability of a particular test can be derived. So there's obviously a lot of mathematical derivation that goes behind all this, which I'm not very expert of. But for our simple understanding, we can move ahead with the understanding that the classical test theory, whatever it proposes, the ideas or the assumptions that it upholds, it can obviously be translated if we administer it to multiple individuals. And that is, I mean, in practice, that is what we see. We obviously, I mean, when we are trying to test the psychometric properties of a particular scale or assessment, we obviously hand it out or we administer it to large number of people and then try to compute or calculate its psychometric properties, reliability being one of them. So if we see here, this same representation in terms of reliability, it becomes the variance of the true score, variance of the observed score is equal to variance of the true score plus variance of the error score. Okay. So if we are to assess or compute the reliability of a particular assessment, it roughly translates to the variance of true score over the variance of the obtained or observed score. So from here we can, if we just compute some values, we would basically see that if the variance of the true score is relatively high in comparison to the variance of the observed score, the reliability is towards it's a high, it tends to be a high reliability. On the contrary, if the variance of the true score is comparatively or relatively quite lower than the variance of the obtained score or observed score, the reliability obviously suffers there, or we can say that the test or the assessment is not a very reliable one. And usually, if you go by this particular representation, our values, or here our values is basically reliability values, they range from 0 to 1. So basically, it is a kind of a proportion that we are trying to arrive at. So the higher the proportion, the higher the reliability of that particular assessment or tool. Next, we'll be discussing some item level statistics, how we can understand the different item level characteristics through the theorization of classical test theory. So we'll start with the descriptive statistics. So with any analysis, we researchers, we are mostly interested with the descriptive statistics at the very beginning. So even for, or even at item level analysis, we look into the descriptive statistics first, which does give us some useful clues about whether an item is a good item or a bad item. So what discriminates a good item from a bad item, we'll be discussing those in terms of these psychometric properties. We'll be discussing somewhere around 2 to 3 of such characteristics. The first is obviously mean and SD in terms of descriptive statistics. It can provide clues on the usefulness of an item. So if you see here, it says that if the mean of a particular item is at the center point of the distribution. So if you have a set of scores on a particular item and we plot it on a particular XY axis, if it comes, or if the mean comes out to be at roughly at the center point of the distribution, and also it has a high standard deviation, we term that item to be a better performing item. So it has a good amount of variation around its mean score. So that is one of the useful indicators that can tell us whether an item is a good item or a bad item. So mean should be at the center point of the distribution, and the standard deviation should be high. And that is one indicator through which we can discriminate a good item and a bad item. Next, we come to difficulty level of a particular item. Come to the difficulty level. How can we gauge or how can we assess how difficult or how easy an item is in terms of classical test theory? It gives us a measure of individual test items difficulty. So when we are trying to analyze whether or at what level does our test or assessment comprises of easy, moderate, or too difficult items. Technically speaking, a particular good test should have a range of items ranging from easy to difficult. So it should not be that all the items or most of the items, the majority of the items are too easy or too difficult. That would not lead to any beneficial outcome in terms of any analysis. So it is how we calculate that under classical test theory is that we have this formula here. It says difficulty level can be computed as a proportion of number of correct responses over the total number of individuals. So let's say we have, let's say, 10 individuals taking a particular test, and how many of them have correctly responded to a particular test item. So let's say out of those 10 individuals on item 1, around 8 of them have correctly responded to that particular item. So that would say that 80% of the individuals have correctly responded to that particular item. So if it is 80% or above, it is considered to be too easy. Somewhere between 20 to 80%, if that is the proportion of people who get an item correct, we usually tend to bring it under the moderate category. And if we have less than 20% of the individuals or participants getting a particular item correct, then we term that particular item to be too difficult. This is a very straightforward way to determine whether a particular item is difficult or easy. So once we have this estimate, we can definitely play around with how many items should we have in our assessment, or how many items should be easy, how many items should be moderately difficult, how many items should be fairly enough difficult. Okay, so basically we can ensure the variation in the difficulty level of our test items in a particular test. Next, we'll have a look at a particular hypothetical data. So this is one hypothetical data that will help us understand which items are having a high difficulty level or low difficulty level. Okay, so here basically we have 10 individuals. The column which says ID here, this shows that there are 10 individuals here. The test has 10 items in this particular data set, and this total score column, it gives the percentage of the total score that each individual has obtained. So we can see that the first individual has got all the answers on all the items correct, right? The next participant has got out of 10, they have correctly answered 9. Okay, similarly for others as well. Now, if we look at this column which corresponds to the second item, we see that the difficulty level here is 1. Why is that? Because for all the, for this particular item, all the individuals have got this item correct. Okay. So hence, by going by the formula that we discussed, total number of correct responses by the total number of individuals, we get a difficulty level of 1, which is very, very high. In here, we have to remember that.
Sorry for interrupting, but we are not able to see the slide of the table.
Okay. Is it now visible?
Yes, now it's visible. Thanks.
Yeah, thank you, Ananya. Okay. So I was trying to play it in the PowerPoint mode, but hopefully I think it's not working. So I'll just go ahead with this. So this first this the second item here. So we can see that in the second item, all of the participants or all the individuals have got the second item correct. So the difficulty level that we obtain is going by the formula that we discussed, it's coming out as 1. So we have to remember here, the higher the difficulty level, or we call it difficulty index. So the higher the difficulty index, the easier the item is. So out of all these 10 items here, we can see that item 2 is the easiest item. Why? Because everyone has correctly attempted it, right? Next, moving on to this item 6, which is highlighted in green. So this here we see the difficulty item is 0.8, right? It is again towards the higher end of the spectrum, indicating that it is still an easy item, but it is not as easy as item 2, where all the participants have got it right. Next, we have this item 4 here, if we see highlighted in navy blue. So here we see the difficulty index is 0.5, which is fairly moderately difficult. Only five of the individuals have got it right, and the other 5 have not got it right. Then we can have a look at this item 9 here, highlighted in red. So here we see the difficulty index has dropped to 0.4. Even though this, going by the categorization, it is still a moderately difficult, or moderately, yes, we can say moderately difficult, but we can say that it is not as difficult as going to the difficulty level of 0.2 or 0.1. Okay. So out of these 10 items that we can see here, if we are to judge which is the most difficult item among all these 10 items, it is this item 9, and the most easiest is item 2. So item 2 is one such item which can be easily discarded. Why? Because we do not want such easy items where there is no variation in the scores here. Okay. So we want some variation in the scores. Also, on the other hand, if we have some item where everyone got it incorrect and we get a difficulty index of 0, right? Even that item, we should be careful enough to remove from our item set. Okay. So this is one way where we can ascertain the difficulty level of our items, and decide based on these difficulty indices, we can decide which items to retain, which items to let go of. Okay. Now there are obviously certain threats to determining these difficulty level. What are these possible threats? We can see here unfamiliar terminology. So most of these threats here basically relate to how we frame a particular item. Okay. So unfamiliar terminology or complex item format, something that is not comprehensible by our target sample, or unclear instructions. Instructions are not clear to the individuals or the participants. Ambiguous items, right, which convey different meanings to different people. Those kind of items. Confusing text, okay, where the intended meaning is not being understood by the target sample. Okay, so these are some concerns that can pose a threat to difficulty level of a particular item. They can unnecessarily make a particular item difficult. So we need to be very careful while we are framing our items for a particular test. Here is an example of an irrelevant item. You can see it says, in which season do we celebrate Halloween? So if we are administrating such an item to, let's say, someone from rural India, okay, where they might not have even the understanding what Halloween is. Okay, so for that kind of target participant, this would not be a relevant item. So even though this item would seem to be fairly easy for those who have some understanding of the Western culture, uh, for them it might be easy for them to understand. It won't be a difficult item, but just because of the nature of the item, it would become difficult for a person who has absolutely no understanding of the context of this question. So such questions should be avoided, right, which is not even relevant for our target participant. Next, the last thread that we can discuss is implausible distractors. This is more applicable where we have obviously options where one option is correct and the others are incorrect. So we have two examples where one represents a weak item, the other represents a strong item. So on the left hand side, we can see that the question is the same, how much is 2 to the power 3, but based on the options that are given, one is a weaker item, the other is a stronger item. How do we determine that? So if you look on the left hand side panel here, we can see that the options that are given, even if someone who does not have this basic mathematical understanding of which of how to calculate a number raised to a particular power, uh, they might make a particular guess, and it is very likely that their guess can come out to be correct. Okay, why? Because the responses or the response categories or the options that are given here, they're very easy to logically make sense of. Like the first option here is 0.8. Okay, so it is too small for this particular expression here, 2 to the power 3. Okay, it cannot come out to be in point. A very logical derivation. Then we have the option C. It says 80, which is a very big number in comparison to 2 to the 2 raised to the power 3. Similarly, D also, option D, it is again too big. Okay, so even if someone does not have the basic idea of what the answer could be, they can take a guess, and it is very likely that the guess would come out to be correct. So this particular example is an instance of a weaker item. But on the right hand side, if we see, the options are such that, or the other distractor options are such that one has to have some basic understanding of such a computation to arrive at the correct answer. Okay, so this instance on the right hand side, this is a more a stronger item as compared to the previous one. So we need to make sure when we are framing such questions, we should not make or we should not select such distractor items which would be very easy for someone to discard based on some basic logical reasoning. All right. So these were some of the ways in which we can be mindful of preparing our items or ensuring that our items are not too weak in terms of their characteristics and how we present them, how they are comprehended. This was about the difficulty level. Next, we come to discrimination index. Now here, we basically measure the effectiveness of an item in discriminating between high and low ability students on a test. So if we are to assess whether a particular item is a good item or a bad item, another way is through this discrimination index, which would tell us whether that particular item is successful enough to discriminate someone who has a higher ability as compared to someone with a lower ability on that particular test. Okay, so logically speaking, all high ability students or participants, we can say, will tend to choose the right answer. On the other hand, low ability participants or students I'm saying because in terms of any assessments, okay, will tend to choose the wrong answer. We have the formula here. So I'll just briefly say the steps that we follow here. If we have a particular set of data, we pick a portion of those who have scored towards the higher end of the total score spectrum and those who have uh, scored towards the lower end of the total score spectrum. Okay, so let's say we can have two separate groups where one group is comprised of top 25 to 30% of the those who have scored higher, and the lower or the bottom 25% to 30% of the individuals who are on the lower spectrum of the entire total score spectrum. Okay. So the formula for computing this is number of correct responses in higher groups minus the number of correct responses in lower groups. This whole thing divided by total number of students in each group. So this can give us an estimate of whether a particular item is discriminating higher ability individuals as compared to lower ability individuals. Next, we'll try and understand this with one particular data set. So let's look at this particular table here. The first column is the item numbers. I hope the slide is visible. Yeah. The first column is obviously pertaining to the items that are there. There are 10 items that are listed out here. The second column is upper group. Upper group basically this comprises of those who have scored in the top 30s or top 25% of that entire group. Okay. The next column is the lower group, that is bottom 25 to 30%. We also have the difficulty index is given here, and the last column is that of the discrimination index of these items. So if we see the boxes in highlighted in red, item 2, 3, and item 9. Okay, these are the ones that are not discriminating among the upper group and lower group. Our aim here is to pick out or identify those items which actually can discriminate the upper group and the lower group in terms of their scores on those particular items. So if you see for item 2, 5 individuals have got that item correct, and in the lower group also 5 individuals have got that particular item correct. So hence the following the formula that we discussed, the discrimination is coming out to be 0. That's hence this item is not at all discriminating between the upper group and lower group. Also, if we take into consideration the difficulty level, it is 1. Okay, so it is so easy for everyone to answer this particular item correctly that there is no distinction between the upper group and lower group. So we can easily discard such items. If you look at item 3, this again, here also we don't see much difference in the number of individuals in the higher and lower group. But one thing to take into consideration is the difficulty level. So we see here difficulty level is 0.8. So we need to be mindful of whether we want to discard it or not. Okay, because here item 2 can easily be discarded based on both its difficulty level and discrimination level. But where we have variation in the difficulty level, there we need to be a bit mindful, and it depends on the researcher or on whoever is conducting or preparing or devising that particular tool. It has to be based on their own judgment and decisions whether to retain that particular item or discard it. Another item that can easily be discarded is item 9, where we have a discrimination index of minus 0.4. Okay, so here we see only one individual in the upper group has got it correct as compared to 3 individuals in the lower group. So obviously this is a very mindless outcome that we are seeing, that cannot be logically fathomed here, that those in the lower groups are getting it correct, whereas those in the higher group, they are getting it wrong. So we can easily discard such kind of items as well. Now if you look at item 5 here, we see this is one item that has a good discrimination index, where 5 individuals have got it correct in the upper group as compared to 2 individuals getting it correct in the lower group with a difficulty index of 0.6. Okay, but we can also compare this with item 4, where the discrimination index is the same. Okay, but one of the difficulty index is different from 0.6. So this item 4 is comparatively more difficult as compared to item 5. So even if more individuals are in the upper group are getting it as correct, some of that can be attributed to the difficulty level. Why? Because the difficulty is, the item is comparatively easier as compared to this item 4. So even if the discrimination index is the same, they might vary in the difficulty index. So these issues should be taken into consideration when we are deciding on whether the item is meaningfully discriminating between the higher group and the lower group. Okay, so these are some of the considerations in terms of discrimination index. Next, what we can also do is we can plot the difficulty indices based on the different total score percentiles. So here in this particular diagram, we can see 4 items have been plotted based on their difficulty level. So on the y-axis, you can see it's written P levels. So this P levels is nothing but the difficulty index of the items. And on the x-axis, we are observing, or we are plotting the total score percentile. So we have the percentiles plotted on the x-axis. So I'll pick up one or two items from here for us to understand what is happening in this graph here. So let's look at this item 2 here with the black dots. So if we look at this, we see that the discrimination index, it is gradually increasing from the 10th to the 30th percentile. After 30th percentile, this graph somewhere plateaus out, and towards, by the time it reaches the 99th percentile, it is experiencing a slight decline also. Okay, so this is, we cannot consider this as a particular good item. Okay, it does not really discriminate at the higher end of the ability spectrum. Okay, so it should have shown gradual increase for us to consider it as a good item. Contrary to this, we can also have a look at item 3 here with triangles. If you look at this item 3 also, if we closely observe, from 10th to 70th percentile, there's not much discrimination going on here. Okay, it is absolutely flat till 40th percentile, and slightly increases after the 40th, and till 70th, there is some slight, very negligible increase in the discrimination level. But after the 70th percentile, we see there is a very sharp increase in the discrimination. Okay, which goes on till the 99th percentile. So this is another item which needs a lot of thought on the part of our decision to retain such item or not, because it even if it is not discriminating till the 70th percentile, it is actually discriminating at the higher end of the ability spectrum. Okay, so this such items need a little bit more thought, or maybe we can think on revising such items in order to retain them. Okay, a particular example of a very good item or excellent item over here is item 4. So if you look at, which is comprised of small boxes, if you see, so this particular item, if you look at the graph for this item, it is more or less a straight line, and it is gradually, it is increasing as we move from 10th percentile to 99th percentile. So this gradual increase with the increase in the total score percentiles, this indicates that those who have lower ability will obviously have a lower probability of getting this item correct, and those with a higher ability will obviously have a greater probability of getting this particular item correct. So item 4 is one example of an item that has a high discrimination index. Okay, so we can also not only can we compute the indices, but we can also make use of such graphs and plots to have a visual understanding of how our items are performing, and that can also assist us in taking decisions of whether we want to retain certain items or let go of certain items. Next, we come to another component that can help us take decisions on whether items should be retained or discarded. So this particular component is item total correlation. Okay, so it basically tries to answer the question, how do responses to an item relate to a total test score? Okay, this particular question is obviously coming from the assumption that if a particular person is responding to a particular item, either it is correct or it is incorrect, or if it is in a Likert type rating scale, whether higher ratings are corresponding to higher total test scores or not. Does that hold true under classical test theory or not? So that is the entire idea behind item total correlation. So for that also we can do certain computations, which is nothing but computing correlations among a particular item score and a particular total score, which we call the total test score. Okay, so for Likert type items and for dichotomous items, we use different kinds of correlations. So for Likert type, we simply go ahead with the normal Pearson product moment correlation. And for dichotomous items, we go ahead with either Pearson point biserial or biserial correlation. Okay, so depending on the type of response our items warrant, that will decide what kind of item total correlation we would be computing. So let's try and understand this using some data. Okay, so here we have a particular data set where we are trying to correlate the responses on one particular item where the response type is Likert type response. Okay, so on a scale of 1 to 4 individuals, there are 20 individuals here. Each individual has responded to that particular item and they have given their responses in terms of whichever response category or response type they want to select. Okay, so we see that this second column, all the scores here revolve from within 1 to 4. Okay, and we also have the total test score. Now this total test score, usually classical test theory, it suggests that we should compute, or we should take into consideration the corrected total test score. Okay, what do we mean by this corrected total test score? Corrected total test score is where we do not take the score of that particular item while computing the total score. For instance, I'll tell for participant 1 has responded to item 1 in terms of 3. Okay, they've selected the option 3 for responding to this particular item. And we also have this total test score. This total test score, if it is a corrected total test score, it will not have this 3 included in this total test score. There's a reason behind that. Why we do not want to include that? If we include it, chances are that the correlation that we'll be obtaining will unnecessarily be inflated and we'll get a high correlation. Why? Because this total test score is including the response for that particular item for which we are trying to compute the item total correlation. I hope this part is clear. If anyone has any question, I am happy to repeat it.
So we have to subtract the score of that participant from the total score, and then we will correlate.
Yes, yes. So if for we are trying to compute a particular item total correlation, uh, when we are taking the total score for that particular individual, we do not include the score for that particular item. We remove that particular item, I mean the response or the score on that particular item from the total score. That is the idea behind total test score. Okay, or corrected, we to be very specific, it is corrected total test score, total score. Okay, so this 34 here, I'm assuming these are corrected test score even though it is not written here. So this is 34 does not include 3 into its computation. So it is devoid of this particular score for participant 1. So in reality, the for participant 1, the total score would come to 37 if we include this item as well. Okay, score on this item. It would come to 37. But if we are to compute the item total correlation, we are not including this 3 within their total score. I hope I have made sense so far. Okay, yeah. So we have, based on formulas of product movement correlation, this entire data set, if we compute using the formula, or nowadays we don't even require formulas, but just for our understanding and some recapitulation of these formulas, I've put them on the slides. So much of this can be easily done on SPSS or R, maybe SIR or other faculties will take up this in the next sessions. So for this particular item, the item total correlation is 0.64, which is not a very high correlation, but it is high enough, or we can say moderately high enough for us to go ahead and retain this item. Okay, anywhere below 0.4 or 0.3, that indicates that that particular item is does not have a particular level of discriminatory power. We can discard such items where item total correlations fall below 0.3 or 0.4. There are different cutoff points based on different estimates given by experts, but generally speaking, less than 0.3 or 0.4, such items should not be considered, or they should be either discarded or maybe modified for better performance. So this was in terms of continuous variable, right? So classical test theory, it assumes even though Likert type response is not really continuous in nature, but again, classical test theory allows us to simply go ahead with Likert type response and assume that they are continuous in nature. Another scenario could be with in terms of dichotomous response. This is another scenario where we have the response categories can only carry two values, that is 0 and 1. Okay, so in such scenario, we have to compute the point by serial correlation. Okay, if it is truly dichotomous. If it is not truly dichotomous, obviously we have to go with biserial correlation. Okay, so here also we see that now this kind of assessment or this kind of analysis is required mostly for cognitive tests where we have correct and incorrect responses, where I mean there are not more than two categories of responses. So any such scenario, we do not go with product movement, we go ahead with point by serial correlation. Lastly, we come to some limitations. So this was whatever we discussed so far. These were all the different types of analysis that can be done to understand the characteristics at item level. Right at the beginning, discussed that a total test score is as good as its components, right? So if items themselves are ambiguous, or they do not have enough discriminative power, or there is no variation in the difficulty levels of the set of items, that all can impact the total score. And any analysis based on any faulty total score, that will obviously give us faulty outcomes in terms of any kind of research that we undertake. So it is very, very important for us, especially when we are developing a new scale, or maybe we are trying to adapt a particular scale. We still need to see whether the item properties or the item characteristics, they are upheld, and they are good enough for us to go ahead with any kind of analysis and any kind of generalization. Lastly, we come to some limitations of classical test theory. This is one of the very initial theories that we have in the literature that can help us understand our test items at a very granular level. Okay, but now obviously advanced theories have come into place. That is item response theory. It is a way more advanced way of looking at psychometric properties or item level properties. And those advancements have come because of certain limitations of classical test theory. So we'll just have a look at the points that are the limitations of classical test theory. So much of the difficulty level or discrimination index that we compute, they are not independent of the sample size. Okay, so it is seen that as sample size increases, or even the number of items in a particular test increases, these indices, they are very badly impacted. Okay, there is huge shift in these indices, which leads to a lot of confusion. So it is sample dependent, and it is most useful when the student sample or the participant sample is similar to the population for whom the test is being developed. Okay, so we have to be very mindful of testing a particular assessment tool on the intended population. Even there, sample size would be of a concern. That if sample size shifts, or there are huge shifts in sample size, that can also impact the difficulty level and discrimination indices. Okay, so it is very, very sensitive to such changes in sample size. The next is an individual's ability cannot be judged just based on the number of items answered correctly. Rather, the item attributes such as difficulty level should also be taken into account. This we already saw in one of the previous slides, where while trying to assess the discrimination indices, this particular slide here, even though we were trying to look at the discrimination indices, we have to take into consideration the difficulty of a particular item as well. So even if two items have the same discrimination level, very likely we would not get the full picture unless we take the difficulty of the item itself. So that is another limitation, right? Hence, from that particular limitation can be derived that we cannot just simply base a particular individual's ability on how many number of items have been answered correctly. The next one is multiple forms of a test are considered to be parallel only after much effort has been expended to demonstrate their equality. Right. So there are instances where we try to establish reliability using parallel forms, or two different forms of the same test. Okay. So there also classical test theory faces issues. Why? Because it is very difficult to maintain the same level of equality across items. Okay, maybe in terms of total test scores it can be maintained, but when we have to get down to the granular estimation of difficulty level, discrimination index, it becomes very difficult to maintain this equality. This is another challenge where classical test theory can falter. And lastly, sometimes it is required by researchers, or it is required by experts to convert scores. The reason being that classical test theory is very, very strongly dependent on the assumption of normality of the errors. Okay, so in order to meet such stringent assumptions, experts sometimes have to convert scores, right? Maybe use some standard scores or maybe combine different scores in order to meet these assumptions, which are again some ways of tweaking around with scores in order to just forcefully fit the data to meet the assumptions. But the limitation again creeps in there, that if we are to convert scores or if we are to combine scores in any format, it can strongly influence the indices that we are talking about. So there also classical test theory is limited when if our data does not meet the assumption of normality. Another limitation is that with regard to factor analysis. So if those of you who have some basic idea of factor analysis, where we try to extract dimensions within a particular uh, scale, there obviously dichotomous items uh, cannot be subjected to factor analysis as per classical test theory, which can obviously restrict us from establishing a particular such particular test's validity. For Likert type items, we can still use any factor analysis to derive or extract domains or factors from for that particular test. But where we have dichotomous items, classical test theory suggests that it should not be subjected to factor analysis, which is again it will pose obviously it is restricting us from establishing the validity of such test items where the responses are dichotomous, and especially in terms of most cognitive ability tests where most items are dichotomous. It is either right or wrong. Okay, so for such tests, CTT does not have any solution for that. That is one another major limitation for classical test theory. So that is all that I had to offer. Here are some references that we can look into for better in-depth understanding. One is by Paul Klein, the other is by Downing and Haladnia. Obviously, I will be sharing this PPT with Sir, so he can forward it to all of you, and I'll also be sharing a document by Paul Klein, from which I have taken idea for this particular PPT. So you can have a good reading of all the concepts that I just briefly mentioned here. Thank you very much for your patient listening. If you have any questions, I can quickly take them up because I have a class right after. Yes. Sir, I'm done with the presentation. If anyone has any questions.
I have one question,
Yes, please.
that the basic equation that is used in classical test theory is observed score is equal to true score plus error.
Yes.
So we have used this equation only in one measure, right? To calculate the reliability. For rest of the measures, this equation is not used that we are calculating in CTT.
So from this equation basically is the assumptions are being derived from this equation, right? Yes, you're correct in saying that we are not using this equation apart from where we are using reliability. Even there you would see that we are not directly using this, we are using a particular derivation of this particular equation. Nowhere are we using this equation in a direct format. So there also we are using the variation in observed scores, which is again a summation of variation in true score and variation of the errors, right? Yes, for the other computations, we are not really relying on this, but the idea from where we are going ahead with computing the difficulty index and discrimination index, all these are basically based on this basic premise. Okay, so the logic from where it is deriving is basically this particular expression that we see here. I hope I answered your question.
Yeah, thanks. Just one more question from my side, that true score is a very abstract concept, as you have mentioned already.
Yes.
So, why is classical theory still relevant? Like, why is it still the most popular theory that is being used in psychometrics?
Okay. Obviously, if we look at this mm, basic premise over here, we see logically it should stand correct. If we just go back to the example that I said, that if we administer any test on us, we don't see our scores to be exactly the same at different sessions, right? If I happen to administer, let's say, SPM, for instance, it is one of the psychological tests. So I would not see what score I get today. Tomorrow, if I administer that same test, or maybe after a week I administer the same test on myself, I would not see same score. Okay, so obviously there is variation in whatever scores I'm observing. So X is the observed score, but according to classical test theory, it says that whatever scores I'm getting, that is taking into consideration some errors. Okay, there is an error component due to which I'm seeing this variation in my observed scores. But uh, theoretically speaking, I should always have one particular score for any assessment, that is true score. And that true score obviously is an abstract term, because we do not have there is no way we can prove it. Uh, we have the theoretical understanding that if we go on infinitely administering a particular test for infinite sessions, and we take a mean of those infinite scores on those infinite sessions, we can arrive at a estimate of a true score. Even then we cannot really say that it's a true score, we can arrive at an estimate of true score. But this observed score that we are saying, we can arrive at this observed score through this particular basic premise that we see here. And to answer your question, why is it still relevant? So even the more advanced assessment, or sorry, the even the most advanced theories for item level analysis, like item response theories and all, they somewhere derive their basic uh, premise from CTT. Okay, so even in item response theory, you will come across the same ideas, but they'll also speak about things like probability and the probability levels that possibly make a particular item, or render a particular item as good or bad. So that there is advancement there, but classical test theory is basically provided a base understanding above which all other theories have uh, kind of come into picture. Okay, it's more like saying, I'll just give a rough analogy here, that we all learned basic mathematical operations when we were kids, right? Plus, minus, multiplication, division. But when we moved on to higher level, we learned BODMAS, right? Which was nothing but an advancement over what we had learned, right?
उनका पता कोई ऐसे लोग ना तब तक नहीं पकड़े जाते जब तक उनका कोई बड़ा
Lovely ma'am, can you
होता है।
please mute
कोई
yourself?
बड़े केस में फंसे ना, जैसे किसी का कोई बड़ी चोरी हो, बड़ा जब तक कुछ ना हो तब तक वो पकड़े नहीं जाते ऐसे लोग, और कोई फायदा नहीं उनको बोल के। आप जैसे बोलते
Lovely ma'am, can you please
ज्ञान
mute
की पट्टी
yourself?
पढ़ाओ, कुछ पढ़ाओ, 50 सिमें इतनी, तो पता है 200-300 ऐसे सिमें खरीद के रखते हैं, जमतारा पिक्चर में दिखा रहे थे मम्मी।
Ananya, I have answered your question.
पता क्या करते मम्मी, लड़का देखो मम्मी,
Yes, I
पता
got
क्या
my
करते, सुनो
answer.
तो
Thanks.
Yeah, okay.
मम्मी, वो दो मम्मी देखो, रेलवे की पटरी ना, उसके किनारे बच्चे रहते थे, फिल्म में दिखाया गया था और असली की है।
Sir, are you there?
नहीं, आप 21-22 साल के, ऐसे 18-20 साल के ग्रुप के कम से कम थे 10-15 बच्चा। वो लोग क्या करते थे, लोगों को ऐसी नहीं ऑनलाइन
I
में,
hope Lovely ma'am cannot hear me.
मम्मी
Lovely ma'am, can you
ऑनलाइन
please mute
एक
yourself?
लड़के के पास लैपटॉप था और एक लड़का था जो सिम खरीद के ले आता था, और एक लड़के के पास 50 से 60 सिमें थी, तो अलग अलग नंबर से फोन करते थे। और क्या फोन क्या करते थे कि आपका
End
लोन
the
अप्रूव हो
session
गया,
here.
आपका वो
If you have any
हो गया है।
questions,
आप वहां के
you
है
can
ना, एक लड़का
obviously
था उसमें से जो तेज था इंटरनेट, वो
send
सब
it
डिटेल
to
निकाल लेता था।
sir, and you can forward it to
डिटेल
me.
नहीं है, जैसे अब वो आपसे पूछेगा कि ये
I'll
है,
share
तो वही
this
आपकी
PPT
होगी है, तो
and
आप भरोसा कर लोगे आपको।
Sure, if you have any question, I will send to sir.
Dear students, do you have any question about the classical test theory? If you have any question, please you clarify. Because after that, there will be one evaluation.
Okay, one more thing, in which fields we can apply CTT? Is it just for the testing purpose, or somewhere else we can apply this, the scope of classical test theory?
Hello, Murshida, please you unmute yourself.
Excuse me, sir.
One sec. I'll pass question over.
Yeah, sorry. Yeah. So yes, we can obviously use these ideas when we are trying to understand the psychometric properties at an item level. Okay. So that is where classical test theory is coming. And in terms of fields where we can use it, mostly uh, in those scenarios where we are trying to develop uh, assessment tools, any psychological assessment tool, or maybe any, let's say, marketing assessment tool, okay, where we have questions and we have response categories that can fall under the category of Likert type rating or dichotomous response items. Even when we are adapting any kind of tool, we can also test whether the existing item level properties, they are being retained while we are trying to adapt it. Okay, so yes, we can use it across any behavioral science or any social science areas where quantitative item level analysis is required.
Okay, thanks.
Okay. Thank you, Nanda.
Now, Lovely, please you ask.
Sorry, sir. Sir, can I just say one thing, that I have a class right now. So if anyone has any questions, they can forward the question to you, and you can maybe forward it to me, or I can just share my email ID in the chat box also. So if anyone has any questions, they can just write to me as well. I have to actually rush because I have a class right now. Yes, I've put my email ID in the chat box, so please feel free if you have any questions or you need any material in relation to uh, uh, this classical test theory. I'll obviously be sharing the PPT as well as one reading material with sir shortly, so I can forward it to all of you. Okay. Yeah. So, sir, I think I can leave the meeting now. I'll take your leave now.
Thank you, Murshida.
Thank you so much, sir.
Because you are in that teacher group of
Yes.
classroom.
Okay, sure. I'll share it there as well. Okay, yes.
There you
Okay,
can.
sir. Yeah. Thank you so much, sir. Thank you all the participants. It was lovely presenting to you all. Hope we meet again soon.
Thanks for the great session.
Okay. So now it will be the lunch period, and we will meet at 2 p.m. By this time, I will give you some question in the Google Classroom. Please you fill it up. Good afternoon, students. Am I audible?
Yes, sir.
Oh, thank you. I have given 2 questions. Have you seen?
Yes, sir.
I
Yes,
think
sir.
of this question, this is not very difficult.
Right, sir.
Okay, Madhavi, it is already in the Google Classroom.
Excuse me, sir.
Yes, lovely.
Sir, till I mean, how much time do we have for doing these questions? Do we have to do these questions right now or later?
No, later.
Okay. And what is the deadline of these questions? I mean, till evening, till
Today,
yes.
yeah, till evening.
Okay, sir.
Tonight.
Okay, sir. Okay. So we have to write answers in the space provided in Google form only, sir, if I'm not wrong.
Not the Google form, in the Google Classroom.
Sorry, sorry. My bad. Oh, yes, in the Google Classroom, the space provided.
Yeah,
There only, na?
I think by 8 p.m. you can finish it.
Okay, sir. Before that, I'll do that. Before that, but we have to write in the space provided, na?
Yeah, space is enough.
Okay, sir. Thank you so much, sir. Thank you.
Thank you. This is as per the rules of ISI.
Sir, I have uploaded my documents, sir, Word document in Google Classroom. Is that okay?
Document on what?
So the first assignment, which was on technical session 1, I have uploaded the Word document on Google Classroom. Will that be okay?
No, please, you do not upload anything.
So I have to write down in the class comment, sir.
Yeah. There is a space.
Okay.
Space is there, you can write down there. So that everything will be recorded.
Sir, excuse me. Only these 2 questions are our assignment, or is there anything else which we have
Yeah,
to do apart from
anything
this?
else, because now another session will start.
Okay, sir.
Lovely, you are from which university?
Sir, I'm from DU, sir.
Delhi University. Okay, that's good.
Hello, sir.
Yes, I am sharing the screen now. Okay. This is all about the hierarchical cluster analysis of items. Can anybody tell me what is called item?
Questions presented in the exam, administered in the exam.
Number of series which is given for some particular question.
Okay. Any other characteristics of the item? Whether any question is item, any statement is item.
Sir,
No,
this
sir. No, sir. If the item as well as there is scoring, then the item is called. Then the statement is called item.
Okay. Why we score? Why we score the items? What we
To
get
measure the
after
trait,
the
what we are
scoring?
looking for.
Yes. What
To
are you?
measure the trait, what we are looking for, we can use an item pertaining to the trait which we are going to use. So that we need a score as well.
In the last class, Dr. Murshida Khatun already told you different characteristics of the item. Can you remember? What are the characteristics of item?
Yes, sir.
Yes, Ananya, please.
Mean, standard deviation, and mainly the difficulty of the item. And then we also have item total correlation as a discrimination index.
Okay. That is good. When you are talking about the item discrimination, what do you mean by the item discrimination?
Whether a particular item is able to able to differentiate between the high scoring students and the low scoring students. That is what we mean by item discrimination.
Very good. So the item should have the capacity of individual difference. Okay. If the item does not have any individual difference, we cannot consider that statement as the item. Okay. Now,
Okay, sir.
when we are talking about the items of the questionnaire, we can think about the unidimensional and the multidimensional. Do you have any idea about the unidimensional questionnaire and the multidimensional questionnaire?
I'm not very sure, but the items and the question paper that is measuring different kinds of skill like mathematics, physics, all these geometry. That is multidimensional, and that is just measuring the one skill that is unidimensional.
Okay, so in construction of the questionnaire, we are paying attention to the construct. Okay. What is called construct? Can anybody tell?
Construct is the abstraction of the concept.
Very good. Thank you, Mona Lisa. Construction is the abstraction of the concept. Okay. So suppose I am interested to assess the pro-environmental attitude. So initially, what is important? We have to operationally define the construct, pro-environmental attitude, in such a manner so that the definition should reflect the concept. Okay. Now, when we are talking about the pro-environmental attitude, we can think about the multiple domains. Okay. But there are some questionnaires where we can assess the single domain. For example, state anxiety questionnaire. It measures single domain. So this is unidimensional. When we are studying the personality is the multidimensional construct. Okay. Therefore, the questionnaire measuring personality, that is multidimensional in nature. This part is clear to all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now in the questionnaire, your assumption that the items are measuring the construct. That is your assumption. That means all the items should assess the construct. And for that reason, you are doing the item total correlation. Okay. And if you find the item total correlation is high, that means you can deal with the total score. But when you deal with the total score, then you may lose some of the information of the item. So this is a serious issue in applied psychometrics. Because when there are several items and those items are measuring the same construct, so you are using the total score. And when the items are adding, then what will happen? Each item has separate properties. So that property may be lost. Therefore, we have to pay attention to the item property. Now I am coming to the another model, that is hierarchical cluster analysis of items. Any idea about the cluster analysis? What do you mean by the cluster analysis? Any idea? What is the meaning of cluster? Any idea?
Yes, a particular group based on some attributes, similarity.
Very good.
Those form a cluster.
Very good.
Sir?
Yes.
Sir, cluster analysis or whatever we called it, clustering, it is the task of grouping a set of objects in a in this you set objects in such a way that objects in same group are more similar to each other than to those in other groups.
Yeah, that is true. So based upon the similarity and dissimilarity, clusters are formed. Okay. Now, here you can find out the model. So this is the raw data. So different categories of fruits are there. And there is some algorithm. Algorithm means some logic is there. And following this logic, the three categories of fruits are classified. So we can find out three clusters. These three clusters are the output. So this is the input, this is the process, and this is the output. Suppose you have the 10,000 students and you have administered one academic achievement test. And based upon the academic achievement test, you want to classify all the students into three categories, A, B, C. So how you can classify them? Okay. So that model can be developed using the specific algorithms. So what is clustering? Clustering is the process of arranging a group of objects in such a manner that the objects in the same group, which is referred to as a cluster, are more similar to each other than to the objects in any other group. That means this is the cluster, and this cluster is highly differentiated from this cluster and this cluster. Again, this cluster is different from the other two clusters. Okay, that is the basic assumption. And clustering is called the unsupervised machine learning. Do you have any idea about the machine learning?
Yes, sir.
What is that?
Based on the previous data,
Yeah.
the machine learns based on some algorithm and it works on another data set. Like it learns from the training data set and then works on the test data set to predict what will be the outcome. So there are many algorithms for this machine learning, and this is mostly divided in supervised and unsupervised two categories, and clustering is from unsupervised machine learning.
Very good. So there are two types of machine learning. One is the supervised, another one is the unsupervised. So what is the difference between supervised and unsupervised machine learning, Ananya?
In supervised machine learning, we have one outcome variable. But in unsupervised learning, we don't know what will be the outcome variable. That is the main difference. And there are few methods for supervised learning that like regression and classification. But in unsupervised learning, the outcome variable is not known in advance. That is my understanding of supervised and unsupervised.
No, in case of the supervised learning, we are assigning the label. Earlier, we have assigned the label. But in case of the unsupervised machine learning, we do not make any label. Okay. So, for example, this is the raw data. We are not assigning the label that this red color will be the lychee and this yellow color will be the guava and this red color, those both are red color, but these are the apples. So we have no label. Without making any label, we are doing the analysis. So how we can make this analysis? Initially, we have to find out the attributes. So these apples has some attributes, guava attributes, and the lychees have also some attributes. And we have to find out which attributes are close to each other. For example, this is lychee, and this lychee can be considered as the single cluster. And this is close to the guava. And I find that is the attributes of lychee and guava is different. That means these two are distant. But this lychee and this apple, their color is same, but the size is different. So in terms of color, they are close to each other. But in terms of the size and shape, they are different from each other. Whereas another fruit, which is here, I find that is the total attributes of this object and this object is same. Therefore, I can group this object to this object. And likewise, I can find out that here are other three objects are there. And they are similar to these two. Okay. But others are not similar to the attributes of these two. Therefore, I can make that these five are in the same group. Okay. I think this is clear to all of you.
Yes, sir. Now it's clear.
Sure.
So attribute similarity is important. And what will be the attributes that will be determined by the researcher. So measurement of all the attributes will be determined by the researcher. Cluster analysis is a statistical method used to group similar objects or observations into clusters based on their similarity. The objects in a cluster have high similarity within the group, but low similarity with objects in other clusters. There are two main types of cluster analysis. One is called the hierarchical clustering. Another is called the non-hierarchical clustering, or K-means clustering. In hierarchical clustering, objects are grouped into clusters based on their similarity. And then these clusters are merged into the larger clusters based on their similarity. So again, I find these two are similar to these three. So they are forming one cluster. And when this cluster finds similarity with these three variables or three objects that will be included in this same cluster. Okay. This process continues until all objects belong to a single cluster. On the other hand, K-means clustering involves dividing the data into a predetermined number of clusters and assigning each object to the nearest cluster. In hierarchical clustering, you do not know how many clusters are there. You do not know. But in K-means clustering, you know that is maybe there will be 2 or 3 groups. Okay. So that is the difference between the hierarchical clustering and the non-hierarchical clustering. For example, before K-means, these blue objects and the red objects, they are merged. We do not know. So initially, everything will be the same. Now, when you apply the K-means clustering analysis, then since you have told that there will be the 2 groups, so automatically by the mean, this total data has some mean. Following the mean or the centroid, it divides all the data into 2 groups. And after that, it tries to find out to what extent each object is close to the another object. So they will find out the similarity or the distance from other object. In this manner, they form the clusters because you have requested 2 clusters. So when you get the 2 clusters, after that, you have to do the significant difference in means between the 2 groups. So this is the one group, another this group, whether there is any significant difference or not. Okay. And if you find, okay, there is no significant difference, that means your clustering is not finished. Maybe there will be the 3 clusters or 4 clusters. And after that, you have noted the significant differences. So that is the main thing in the non-hierarchical and the hierarchical clustering. This is the example of hierarchical clustering. This is the agglomerative clustering. That means from bottom to up, And this line is the distance. Now we find eagle and peacock. Both have 2 pairs of legs. Okay. Both have 2 legs and the wings. So, and the typical type of beaks and other attributes. So, among 1, 2, 3, 4, 5, 6, you find that is the attributes of eagle and peacock. They are very close to each other. So they are forming one cluster, and you are giving the name that is the bird. Like that, lion and bear. Both are wild. They are living in the forest. Both have 4 legs. And both have some attributes which are very common to each other. So you are making one cluster. And after making the cluster, you are giving the names. Name is the mammals. And this is one cluster, birds, and this is mammals. And you will find the birds and mammals, there are some similarities with respect to the anatomical structure. Therefore, you are making another cluster. That means from bottom to up, gradually you are making the cluster. And there is spider and scorpion. They are similar to each other. So they are making another cluster. The interesting point is this cluster is different from this cluster. So if it is a primary cluster, this is a secondary cluster. And this cluster is basically the outlier from this cluster. This is clear to all of you?
Yes.
Yes, sir.
Okay.
Your outlier, please tell.
Yeah, this one is the outlier. Because they are forming the main cluster. They are the primary cluster. Okay. And when you include this cluster with this cluster, then you can tell they are forming one cluster, that is the animals. So this is the primary cluster, this is the secondary cluster. And finally, you can consider both as one cluster, that is the animals. From this cluster is different. Again, from this cluster to this cluster is different. Because the attributes of this cluster and attributes of this cluster is different. So this is the important part of the cluster analysis. Is it clear to all of you?
Sir, I have a question.
Sure.
Sir, if we find, like, if we speak about lion and the bear, so bear, they both are carnivore. So what kind of, so what can be called? This thing can be known as what? I mean, the attribute or
It's
something.
written the mammals.
Yes.
Okay. So you can tell carnivals, no problem.
Sir,
But
if we
everything
find some,
depends upon
Hmm,
whether the name that you have given
hmm.
that represents the cluster or not.
Okay.
That is important. So
Sir,
basically, three
Hmm,
states of animals are there. And by using the cluster analysis,
Hmm.
you have noted that is the three categories of clusters are there. And these two categories, they are similar.
Hmm.
And this cluster is different from other.
Hmm.
But when you link all of them, then you will get one major cluster, that is the animals.
Yeah. Okay.
Okay.
Sir, if we find some similarity in the attributes, then what?
Then cluster is possible.
Okay, sir. Thank you, sir.
Attribute, similarity attributes, then
Hmm.
cluster is possible.
Okay, sir. Thank you, sir.
So this is called the dendrogram. This data visualization that I have presented here, it is the dendrogram, and this is the distance. This line indicates the distance. Now steps for hierarchical clustering. Start with individual data points. Treat each data point as a separate cluster. That I have told you. That is, initially you have to think that eagle is the cluster. Maybe single. So because it is a data points. Several data points are there in the eagle. Similarly, the data points have in case of the peacock. So you will find that is these data points of the eagle and data points of peacock are similar. Okay. Yeah. So treat each data point as a separate cluster. Compute distances between the cluster. Calculate the distance or dissimilarity between each pair of clusters. Various distance matrices can be used, such as Euclidean distance or Manhattan distance. Do you have any idea about the Euclidean distance? Square root of the mean differences.
Yes, sir.
Merge the closest cluster. Merge the two closest clusters into a single cluster. This step is repeated iteratively until only one cluster remains. Update the distance matrix. Recalculate distances between the new cluster and the remaining clusters. The method of calculating distance may vary: single linkage, complete linkage, and average linkage. There are different types of distance. Repeat steps 3 and 4. Continue merging the closed clusters and updating the distance matrix until all data points belong to a single cluster. build a dendrogram. It represents the hierarchy of clusters using a dendrogram, a tree-like diagram that illustrates the merging process. The vertical lines in the dendrogram represent clusters, and the height of each vertical line indicates the distance at which clusters were merged. Hierarchical clustering can be divisive, that is top-down, or agglomerative, or bottom-up. I have shown the bottom-up. Okay. The steps described above are the agglomerative hierarchical clustering, which is very much common. Now, some of the keywords. A dendrogram is a tree diagram used to represent hierarchical relationships. It is often used in clustering analysis to illustrate the arrangement of clusters or the relationships between data points. Single linkage is a method used in hierarchical clustering. It measures the distance between two clusters based on the shortest distance between any 2 points in the two clusters. In other words, it considers the minimum distance between individual members of one cluster and individual members of the other cluster. Complete linkage is another method in hierarchical clustering. It measures the distance between two clusters based on the maximum distance. So, single hoche shortest distance and complete linkage hoche maximum distance between any 2 points in the two clusters. In essence, it considers the farthest distance between individual members of one cluster and individual members of the other cluster. So this is all about the cluster analysis. Now I am asking you the question. Do you have any idea about the retest reliability?
Whenever we do the test again and again, same results will be given.
Again and again?
Repeatedly doing the same test, sir, it will give same readings.
Anything more?
Can you please repeat the question?
What is called retest reliability?
So it is data reliability, sir.
What is retest
It's a method to find the reliability of a tool, sir. Say, if I'm going to measure today using a particular tool, after 15 days or say 2 weeks, I can go to the same samples and I can collect the same. I can use the same questionnaire or tool and I can get the data again and I can see whether there is a consistent score between both the data which I have collected.
Wow, very good. So same sample. Another one is the maximum 2 weeks interval.
Sir, were you talking about test reliability, if I'm not wrong?
Retest.
Okay, retest.
Retest reliability.
Okay, sir. Retest reliability, according to me, is the, I think, closeness of the agreement between the results of successive measurements of the same measure when they are carried out under the same conditions of measurement. It's also known as repeatability or test or retest reliability. Sir, am I audible? So this is the closeness or the agreement between the results of successive measures of the same measure. And
Okay.
when they are carried out under the same conditions of measurement.
Wow, very good. Now you have the 5 items. Okay, please you draw. You just write down 5 items. Measuring anxiety. Write 5 items measuring anxiety.
Sir,
yes, Anthony.
This is for everybody, only for us, sir.
No, for all.
Okay, sir. What is the first one, sir?
You write 5 items measuring
Sir.
anxiety.
Yes, sir.
All the students, you have written?
Yes, sir.
Yes, sir.
Okay. So, Varsha, can you tell what you have written?
Sir, I fear walking in darkness. Sir, I'm writing, sir.
Okay. Who has completed? Only 5 items.
Sir, here I just wanted to confirm that 5 items which you were asking, is it the only 5 items or we can also include the scale in that? Because you have also stated that this thing, 5 items measuring anxiety.
Yeah, 5 items measuring anxiety. That
Sir,
is
I will
the
tell you.
rating scale. Rating scale. Okay.
Sir, first one is loneliness, sir.
Which one?
First one is loneliness. The second one is
No,
driving.
5 items. You are talking about the domain. Loneliness is the domain. Loneliness is not the item. It should be the statement type.
I feel uncomfortable before an exam.
Okay. And please you maintain that these 5 items should be correlated with each other.
Do you overeat or under?
Okay, you write the 5 items.
Sir, may I?
Provided all the items should be correlated with each other.
So,
So who is telling?
so let me start with time pressure, social acceptability, mind mapping, competition, and cooperation.
So that is the domain.
So I have to write the variables.
Is it, sir, is it the questionnaire form, in the questionnaire form? While crossing the road, while shopping in the crowded place, that type of question?
Yeah, in just in language, in statement.
In statement form. Okay.
Sir, may I?
Sure.
First item is not being able to stop or control worrying. Second is worrying too much about different things. Third is trouble relaxing. Fourth is becoming easily annoyed or irritable. Fifth is feeling afraid as if something awful might happen.
Okay, so Whether you are presenting the domain or you are presenting the item.
Item, sir.
Item means there will be I am feeling, but I feel. It should be a statement, no?
Okay, sir. So, sir.
Sir, may I, sir?
Sir, may I?
Sure. Okay. Try.
Sir,
who is telling? Please name.
Sir, Lovely.
Okay, Lovely.
Yes, sir. Sir, first one is I often feel restless and and on edge. And second would be I experience physical symptoms like tension or restlessness when I'm anxious. Third would be I find it challenging to relax even in non-stressful situations. And fifth one is there are times when I feel a sense of impending doom or danger. And also, I would like to inform you, sir, these items share a kind of a common focus on anxiety symptoms, but this approach is the concept from different angles. So it kinds of enhances the overall reliability and validity of the measurement.
Okay, you do one thing. You just write down these 5 items. Okay, 5 by 5 matrix you form. And you write down the probable correlation among them. Probable correlation coefficient. Okay. Probable correlation coefficient among them.
Okay, sir.
Just you write down 5 by 5 matrix.
Sir, I have written, sir.
Okay, Varsha.
I fear walking in dark streets. Dark rooms increases my heartbeat. I sweat profusely when I am walking alone in lonely area. I feel giddy when I am in closed room. I feel urgency when when there is power cut.
Okay. So this 5 by 5 matrix you make.
Yes,
and you
sir.
just write down the correlation coefficient among these 5 variables.
Yes, sir.
Sir, I have written 5, sir. May I
Okay.
read it, sir? I feel uncomfortable before an exam. I could not sleep well before the exam. I am too worried about the exam. I can approach exam with ease. I experience restlessness or sweat when I see the exam question paper. So this is related to exam anxiety, as I figured out, sir, after writing.
Okay, it's very good. So please you make the 5 by 5 matrix.
Okay, sir. Thank you, sir.
So may I try, sir?
Sure.
I feel disturbed in being alone. I experience scary in driving in hills. I am scared of touching the electrical appliances. It is hard to feel comfortable in the company of others. It is hard to climb higher in hills.
Okay, that's good. So please you make the 5 by 5 matrix and you write down the correlation coefficient.
Yes, sir.
Any other students?
Sir, I'm Rejani, sir. Sir, my 5 items is I feel very anxious while before the examination start. I feel very anxious while running to oh, I am muted, sir. While while standing in the platform to at to the train,
Please you write down 5 by 5 matrix and the correlation coefficient.
okay, sir.
Bobita, Boishaki,
Sir,
yes.
this is about
Yes.
academic anxiety.
Uh,
So I spend much of my time at school worrying about what is next. There is something about school that scares me. I am concerned about what my classmates think about my abilities. I often feel sick when I need to work on a major class assignment. I have a hard time handling school responsibilities.
Bah, very good. So please you make the 5 by 5 matrix.
Okay, sir.
Can I tell, sir?
Sure.
I get speechless in front of audience. I get sweaty in crowded places. I'm unable to name thoughts in public. I get comfortable when someone compliments me.
Okay.
Is this okay, sir?
Yeah, this is okay. Please you make the 5 by 5 matrix. Devjani Kundu, are you ready? Mohai Menul Bishwas, Madhuri, Ranjit Dhara,
Yes, sir, I'm with.
who is talking? Farah, have you finished?
Not yet, sir.
Done, sir.
Done? Hello, Kavita. Have you finished?
Yes, sir.
Okay. So where do you find the highest correlation? Which items?
With that item only, correlation will be 1.
Correlation 1.
With that particular item, like
Which item?
item 1 to item 1. That will be the highest, but for the rest of others, like I've just given by myself
Yeah, that
the
is
correlation.
by yourself. So why it is highest? What are the items?
Okay. So for me, the highest one is I get fear when I go to stage, and I get uncomfortable when someone compliments. So these got the highest correlation because they are telling about something similar attributes.
Which similar attributes they are measuring?
That I have a fear of stage or fear of being center of attraction.
Okay. So now I am requesting all of you, please you make the hierarchical cluster analysis based upon your data. Okay. And please you make the name. This is clear to all of you. If you find highest similarity, then that will be one cluster. So Ananya, what is the next?
Sir, I'm trying to do it, but can we make this hierarchical clusters by just using 5 items?
Yeah, these 5 items, you can make the cluster.
Okay, sir, I'll try to make it.
All of them are measuring anxiety, but the items, some items are related with each other, some items less related with each other.
So this slide, can you zoom it, sir? I am unable to see it.
Which one? This slide?
Yes, sir. Yes, sir. Hierarchical.
Zoom, okay. Is it okay now?
Yes, sir.
You can take one photo, no problem.
Sir, we can also zoom by using our own screen. Like if we are using logging in through the laptop, then also we can zoom it using the button. And if you're using phone, so then also we can zoom this screen according to our own convenience.
Okay, okay, okay. So Anthony, please you follow what Ananya is telling.
Yes, sir. Yes, sir.
Sir, lovely.
Oh, lovely. Achha, sorry. Why do you not join our course on literature review, lovely? Systematic literature review, SPSS, applied psychometrics. We are providing a lot of the courses. Keep in touch with Farah. Farah can give you.
So, sir, I have divided my items in 3 clusters, like in 2 clusters and then one hierarchical cluster. So
Okay,
the 2 base clusters are stage fear and crowd fear.
very good.
And on top of that, they are coming under the cluster of fear of attention, fear of getting attention. That I've divided in that way.
Very good, very good. Now, can you show the picture?
Okay, just give me a minute. I'll show the picture.
Yeah, yeah.
Should I share my screen or share the image in the chat?
Yeah, you can share. I am requesting all the students, please follow.
Is it visible?
Yeah, this is good.
Okay, so item 1 and item 4 are telling about the stage fear, and item 2, item 3, and item 5 are telling about the crowd fear, and these two are coming under the fear of getting attention.
Okay. This is good, but only thing the missing, that is the line. That is the distance.
Okay, sir.
Agglomerative distance line should be there. That is missing. Another thing, everything is, you have written stage fear and the crowd fear. That is the attention you have written.
Yes, fear of attention.
Fear. But actually you are measuring anxiety. You know? You
Yes,
are measuring
that's also.
anxiety, but you have written fear of attention. Fear of attention, that may be the part of anxiety, but I have told you that is finally you have to measure the anxiety.
Yes, I
Is
can
the,
relate it to anxiety. Okay,
yeah,
got it, sir. I'll try to make it better.
yeah. Main thing, it will be anxiety.
Okay, sir.
Okay. Thank you for your attempt. This is good.
Thank you, sir.
Is it visible to all of you?
Yes, sir.
Okay. I have developed this model that is, instead of the pair T test, or simple correlation between the test and retest score. If we can follow the cluster analysis, we can get maximum information. Therefore, I have developed this model and it has been published in International Journal of Psychological Research. The conventional statistical model for assessing test-retest reliability of questionnaire is to compare composite scores of match subtest or items between periods. Current study examined test-retest reliability in terms of both subtest and item-wise comparison through pair t-test statistics. Data were collected from 72 students twice within 8 months intervals using reading motivation questionnaire. The questionnaire includes 3 intrinsic and 4 extrinsic reading motivation subtests. Finding inconsistency between both subtest and item-wise comparison, I propose a model of clustering items between periods. Hierarchical clustering with complete linkage shows that more than 55% of both test and retest items are assembled in the primary cluster, suggesting high test-retest reliability among 6 reading motivation variables. The problem of assessing time consistency in test items has been the focus of extensive research and documentation in a variety of disciplines. It is a basic methodological step in the process of test development, especially when there is a high probability in changing test item data. For example, Spielberger's state anxiety inventory was administered to Antarctica expeditioners across 3 periods of journey to, living in, and return from the Antarctica. Out of 20 items, only 9 items differed significantly across periods. Chain and Small found poor response stability among stroke patients in assessing test-retest reliability of language imaging experiments. Usually, composite scores across periods are compared in assessing test-retest reliability, resulting difficulty to understand which sets of items are consistent over periods. This study proposes a hierarchical cluster analysis model in order to overcome this limitation. I think test-retest reliability, you know, test-retest reliability is a measure used in classical psychometrics to assess the consistency or stability of a test over time. This type of reliability focuses on the reproducibility of test scores when the same test is administered to the same group of individuals on 2 separate occasions. The idea is to determine whether the test produces consistent results when given to the same individuals at different points in time. Steps: administration of the test. The same group of participants is selected for the study. The test is administered to these participants at time 1, the first testing condition. Time interval: there is a time lapse between the first and second administration of the test. The length of this interval can vary depending on the nature of the construct being measured and the purpose of the test. Re-administration of the test. The same test is administered to the same participants at time 2, the second testing condition. Comparison of scores. The scores obtained by each participant on the first occasion are compared with the scores obtained on the second occasion. Statistical analysis. Statistical methods such as correlation coefficients are commonly used to analyze the degree of consistency between the 2 sets of scores. The Pearson correlation coefficient is often employed for this purpose. Interpretation. The high correlation between the scores from the 2 testing occasions indicates good test-retest reliability. It suggests that the test is stable over time and that the results are reliable. It is important to consider certain factors when interpreting test-retest reliability. For example, the time interval between the test administration should be long enough to minimize the effects of memory, but short enough to assume that the trait being measured is stable. Additionally, external factors such as changes in the participants' experiences or intervention between the two testing occasions can influence test-retest reliability. So this is the method. Initially, questionnaire was administered to 136 students, 70 students of class 3 and 66 students of class 4 of one government school. After 8 months, the reading motivation questionnaire was re-administered to 90 sample as 46 students were not available during the retest period. Among them, 18 students gave incomplete data. So test-retest reliability for reading motivation questionnaire was assessed using 72 data. The mean age for grade 3 students was 8.5 years with SD 0.5, and same for the grade of 4 students was 9.5 years with SD 0.6. This is the reading motivation questionnaire. It was used to examine test-retest reliability of 3 intrinsic and 4 extrinsic reading motivation variables. Intrinsic variables are RH, R no, R app, and R AES, R recognition, R F, and R harm are extrinsic variables. There are 6 items in each subtest covering 42 items in total. For each item, one event is given with answers of 2 options. Selection of option reflects one specific reading motivation. For example, the event is on promotion to the new class of the 2 books. Which would you read first? And the options are application of arithmetic in daily life and B, description of animals of different countries. First option reflects motivation for application and second option reflects motivation for knowledge. High score for each variable is 6, as there are 6 items to measure each subtest. Since scores are binary, item total correlation for each subtest was computed using point biserial correlation, and it was noted that all the coefficients were significant at 0.01 level, suggesting good internal consistency among items for 7 subtests. So this is the pair t-test. You can find out that this is the variable name, APH, APM, APN. So these are the variable name. This is the mean 1 and this is the mean 2. That means test, and this is the retest. And I find there is no significant difference between the 2 groups. That means the traits are relatively stable over the periods. Okay, so these are the domain. APH is the domain. APM is the domain. APN, APP, these are the domain. KNH, KNI, KNK. Okay, so now I find there is no significant difference. And then what I have done the Euclidean distance. And I have noted for APN, APP2, the Euclidean distance is 2.65. And KNI and KN12, Euclidean distance is 2.45. So this is the Euclidean distance. I have told you, you make the correlation. So instead of the correlation, you can apply the Euclidean distance, but it is better to follow the correlation in case of your assignment. Now, this is the interesting result. So this is the KNH and KNH2. That means this is the first test, and this is the second test. And when I have done the hierarchical cluster analysis related to the knowledge motivation, I find that is these two items, they are very close to each other. That means test-retest reliability for these items are very high. And again, this is also 1 and 2. You can find out this is 1, this is 2, this is also close. Similarly, we can find out this item and this item also test and retest. So 2 means retest. So we find that is almost all the items, that is test and retest items, they are close to each other. Okay. Therefore, they are making the maximum information about the relationship or the distance or the similarity between the items over the periods. And this is the achievement motivation. This is another domain. And we can find out ACHJ. Here is ACHJ and ACHJ2 is here. So it should be here, but it is here. Okay. And again, ACHQ and ACHQ2. This is close. So this item is stable. ACHR and ACHR2, this is also close. So this is stable. These two items are also close. But this item, this ACHJ2 and ACHJ, these two items, they are not very close. That means these two items are not very stable. Whereas the other items, they are relatively stable. Therefore, we can find out the different clusters. In earlier, we can get only the primary cluster. So these are the one group of cluster. And this is another group. Maybe the distance is high, but they are following the closeness between these two. But here we find there are two broad clusters. This is one cluster and this is another cluster. But important part is these variables, they are very close to each other. Okay. Now I am giving you some data. Farah, have you given the data?
Yes, I've sent it to you on WhatsApp.
Okay. In the Google Classroom? No, no.
I cannot post.
Oh, what? Okay. Acha, do you have the Art Studio? Lovely, you are in the group. Please you open your Art Studio. Okay, I am sharing my paper. I find my paper so that would be easy for you. After that, I will go to the art studio. So this is the paper. From this paper, I am telling you. So these are some of the items, and this is the main difference between the two tests, pair T test. After that, I have done the Euclidean distance. So these two means second retest data. And in the diagonal part, it will find that is a 0. So when I am trying to find out APH is close to this is 5. APH is close to 4.47. Okay. But APM is 5.48 and APM2 is 5.29. So they are close to each other. So based upon this Euclidean distance, you can find out the closeness. To what extent one data is similar to another data. After that, I have done this analysis. This is the dendrogram. And I have noted that is in case of the intrinsic motivation, intrinsic reading motivation, the items are relatively stable, but the items are not very much stable in case of the extrinsic motivation. Okay. For example, this is the recognition motivation. This is the extrinsic motivation. And you will find that is the items are not very stable over the periods. This is the punishment related. Again, you will find more number of clusters are there. Here it is affiliation motivation. More number of clusters are there. So the theory is that in case of the extrinsic reading motivation, you will find the items are not very stable. But in case of the intrinsic motivation, items are relatively stable. Okay, now I am going to the data set. Acha, Farah, you have given only the two columns.
Sir, universalization, sir, test retest data and this thing, the main test data.
Yeah, I find only the two columns are there.
Yes, sir, two columns, sir.
Now, in case of the test, there are 5 done.
Yes.
UZ1 includes 5 data and another one, UZ2 is the 5 data.
Sir.
Written only the V2 and Tier 2.
Okay. So 1.
You gave me UZ1 and UZ2.
Yes, sir, 1 second, sir.
Or the data frame data UZ3. That is both UZ1 and UZ2 will be there.
ওই জন্য পুরো সব শেখাটাই
Farah, it is your in your laptop.
Yes, sir. I'm just putting sir one last word value I have to put. Just give me.
UZ1 and UZ2.
Yes, sir.
It is in your laptop.
Sir, I've sent you on WhatsApp, sir.
Thank you.
Yes.
Okay. Okay, dear students, please you follow the data. This is visible to all of you.
Yes, sir.
So this is a rating scale. It assesses the attitude towards the universalization values. And here you can find out some of the items: V2, V16, V30, V44, V58. So 1, 2, 3, 4, 5 items are there. So this is the test data. And this is the retest data. TR2, TR16, TR44, TR55, TR30. Okay. So what is our assumption? Assumption will be V2 will be close to which item? Who can say?
TR2.
TR2.
Correct. Similarly, V16 will be close to TR6.
TR16.
So that is the basic assumption. Okay. So we have to find out whether these things happens or not. If it does not happen, that means this item is not very stable over period. So now I am showing you Art Studio. This is visible to all of you.
Yes, sir.
Okay. So now I can write down UZ, that means universalization, equal to read dot table bracket file equal to clipboard. Why clipboard? Because I have copied the data. Then header equal to T. That means variable name. Shape equal to within double inverted comma T. So if I want to see whether I have imported the data properly or not, then I can write down view UZ. Okay. So now I find my data is good data. I can check more. DIM UZ. So I find 34 caches are there and 10 columns are there. Okay, 34 rows and 10 columns. This is okay. Now, what will be my purpose? We have to transpose the data. So I can write down ZT variable name, then T bracket UZ. Okay. Now I want to check whether transpose is okay or not. Okay. Now I find the transpose okay. I have done the transpose. Now after that, I have to calculate the Euclidean distance. So I am writing distance at a variable name UJT dist. This is a vector name as you like. Whatever the things you want to do, you can write down. Dist is the function UJT. Okay. So I am getting the distance. If I want to know whether I have received that everything correctly, I can write down, yeah. So now I find the Euclidean distance. This Euclidean distance is clear to all of you?
Yes, sir.
Okay. Now, next class is the UJT classed. So I can write down H classed. Bracket H classed means hierarchical cluster. Hierarchical cluster of what? This distance. U Z T T I S T. I have done the cluster. Okay. If I want to know whether this cluster I have done, I can write down. Okay. So cluster is done. It is written. Cluster method complete. Distance is Euclidean. Then I can write down plot. P-L-O-T plot. U-Z-T class. Okay. So I have received the plot. So this plot indicates that is the item V44 and TR44. They are close to each other. So this item is basically the stable item. And this item V58 and TR58, they are also relatively stable. But other items are not very stable. Okay. V16 came here. V2 is here and TR2 is here. If we think about this is the primary cluster. In the primary cluster, I find two items, they are good. But other three items, they are not good. So I can find out maximum information, okay, by using this hierarchical cluster analysis. And if we want to do the correlation, COR, then UZ T. Okay. So I am getting, this is the correlation matrix. So it becomes very difficult to interpret your data. But if I do this thing, then it will be very easy. And here you can find out the height. The TR30, TR30 item, that is one item, TR30. And this is the V30. Now you can find out this TR30 is not stable. That means if we follow the hierarchical cluster analysis, you can give the maximum information about the items instead of the pair T test or the simple correlation. Okay? This is clear to all of you or any question?
This is clear.
Okay. So if you follow hierarchical cluster analysis, you can classify the people into different categories, as well as you can classify the variables into different categories. Two things are possible. And if you study what is V58 and what is T58, these two items, and then you can make the one group and you can make one cluster. Similarly, here you can find out the similarity between the two. And if you know what is this item and what is this item and what is the common thing between these two items, then you can make one name out of this. So this is the next point of the hierarchical cluster analysis. It is not the PCA, it is not the principal component analysis. It is the cluster analysis. So do you have any question about the cluster analysis? Okay.
The benefits of using cluster analysis, that is different from other models like.
Yeah. From other models, from the pair T test or this correlation.
Yes.
You will get more, much information in the cluster analysis, hierarchical cluster analysis. And this is possible through the machine learning. By using the machine learning, you can easily classify the people into different categories. Similarly, you can classify the different items into the different categories.
Sir, hierarchical cluster analysis, is it possible in SPSS or AMOS software?
Yeah. SPSS is possible.
Okay.
Everywhere it is possible.
Does it also help in the construction of test?
Yeah, definitely. It helps.
Okay.
Because it provides a lot of information to you about the characteristics of the items. Two things are important. One is the researcher's own assumption about the nature of items. Another one is the cognitive map of the participants, of the respondents. So whether the cognitive map of the respondents and the researcher's own assumption similar or not, that can be tested by using this cluster analysis.
Okay.
So you were thinking that these 5 items are measuring universalization, but your subjects or your respondents, they are not perceiving as the item for that measures universalization. You are thinking that these items will be stable, but your subject opines that they are not stable over time. So you have to tell why it is not stable, what are the underlying reasons for it. That is important.
Okay.
Now, in
Excuse
one
me,
of
sir.
my study, my one student, she did PhD under my guidance, and she is now professor of IIT Kharagpur. She collected data about the job satisfaction as the pilot study. And again, for the final study, she collected data about the job satisfaction. And I have noted that the job satisfaction score between these two periods are totally different. They are not very significant. Then I find that she collected data from the rural banks. And it was the period of Manmohan Singh. And Manmohan Singh, during this period, this gap, declared that rural bank will be scrapped. That means the employees of the rural bank during the pilot study, they were not very anxious. But during the final study, they were very much anxious. Therefore, the reliability of the items or the questionnaire, that differs. So you have to think that is why the items differ between the periods. Okay.
Sir,
Yes.
sir, in case of my study, one PhD study, that is music after response, after giving music therapy, response from the participant, it may differ. Can I apply this in this feedback response form?
Definitely, this model you can apply, and then you can find out that is which experience is
Yes,
similar over the periods and which experience is dissimilar over the periods.
Oh.
That is possible.
And there are 10 items in the questionnaire, and 2 or 3 of the items are not so beneficial or so very significantly not respond from my participants.
Yeah, then you have to think that is if you remove these 3 items, whether the other items are working or not.
Yes, other items are working.
Then you have to
Only
assess the retest reliability by using this cluster analysis.
7 items I can use after retesting. I can use the cluster analysis.
Yeah.
Okay,
I
thank you.
have written I have written the script. So please you follow the script so that it will be easy for you.
Okay, sir. Thank you, sir.
Sir,
I
excuse me.
definitely try.
Yes, lovely.
Sir, just wanted to ask that is there any separate group for for the students in information where everything like you were also mentioning that you also uploaded your published paper. Earlier, I was part of it, but now I have checked twice in my phone also. It's not there. So could you please share the link? If the group is there, then it's fine. If not, then also it's okay.
No, we have the group particularly for different courses. For example, now literature review course is going on, and some students, they have joined here also. So they are learning literature review in the WhatsApp group.
Sir, but I am not in that group, sir. So requesting you to share the link, please, if possible.
No, lovely. This is the registered group. So they have paid the amount and they registered. So
Okay,
when
sir.
we make another group, so then definitely. Okay, Farah, please you maintain the name of Lovely.
Yes, sir, but the course is now going to end after 4
Yeah,
years.
course is going to be end now.
Yes,
So,
sir. So now we
Sir, I
cannot
am
join.
asking about a general group. That is there, apart from those separate group, is there any general group on which all the students are added, and whatever workshop or kind of seminar you are having, so that we can have that information? In general, I'm asking, not the particular group, sir.
no, in general, I think we do not have. We have the alumni group. They are the students of our institute.
Okay, sir. Okay, sir. Thank you.
Correct. Otherwise, you keep in touch with my Facebook account. There you can find me. I usually post everything. And the INSPA group, IAP group, IHP group,
Sure, sir. Thank you so much, sir. Thank you.
there I have posted.
Good evening, sir.
Acha,
Hello.
please you write the script so that in future you will be not in trouble.
Good evening, sir. I just have one doubt, sir.
Yes.
When to use cluster analysis and when to use factor analysis, sir? While
Factor,
constructing a factor analysis, when I am constructing a tool.
yeah, when you want to construct a tool
Mm.
for the confirmation,
Okay.
then you can do the factor analysis.
Okay, sir.
And when your data, your sample is not very large,
Okay.
small data you have, then you can follow the cluster analysis by equilibrium distance.
Okay.
But in case of the factor analysis, you should have very large number of data. So what is the advantage? Because in case of the factor analysis, they will find out whether the two items, they are significantly correlated or not. But
Okay.
cluster analysis, hierarchical cluster analysis,
Okay.
they are not studying your significance level.
Okay.
They are thinking only the items are close to each other or not.
Okay.
That is the distance. It measures the distance between the two items. Euclidean distance they are following.
Okay. Okay, sir. Thank you.
Okay, so I will give you another question. This technical session 2, I will give the question, please you answer. By 8 you finish. So now I think is for closing the session. Good night and best wishes to all of you for joining today's program.
Sir, can we get this data set to just try the code?
Data is already given, no?
No, I haven't received it. Is it given in the Google Classroom?
Okay. This data that I have given, that is available, I think.
যদি বমিটা বমি গ্যাস কম হয়ে যায়, বমিটা হয়ে গেলে, আর যদি বমি যদি না থামে তাহলে কয়েকটা ওষুধ যেটা দিল্লি পাঠালো ওগুলো নিয়ে আসবো বমির জন্য কম করে।
Google Classroom, no? Google Classroom. Okay, I will give this data later on. Okay.
Thank you, sir.
At this moment, it's not working. I will give it.
Okay, thanks, sir.
Okay, thank you, everybody. Please do join tomorrow at the same time.